Hello students, Secondary 1 Chemistry. Today we are going to talk about the mole. We know that any substance consists of very small building units. The smallest building unit that can participate in a chemical reaction is called an atom, which is the smallest building unit. The molecule is also a very small building unit, but the molecule is generally greater in size than the atom, bigger than the atom. For example, the molecule of water consists of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. The molecules of water are separated from each other. This is a compound. This is an element. The smallest part is the atom. It's an element, no other types of atoms here. All the atoms of copper, and so on. Here is another molecule, but this is not in fact a molecule. The molecules are not separated from each other as in the case of water, so the formula here is called formula unit, not molecule. Atoms and molecules are mixed together, as it is clear from this figure. Sodium chloride, sodium ions and chloride ions mixed together in the ratio of 1 to 1. So the formula of sodium chloride is NaCl. The atom is the smallest building unit of the substance that can participate in a chemical reaction, while the molecule is the smallest part of the substance that can be found in a single state. Here's an atomic mass. What is the atomic mass? In the periodic table, the elements are arranged according to the atomic numbers. Each square in the periodic table contains a symbol of the element, and down each symbol of the element there is a number. This number is the atomic mass. The unit of the atomic mass is AMU, which is called atomic mass unit. This unit is very, very small. It's not a practical unit used in the lab. The unit in atomic mass is very small, so we replace the atomic mass unit AMU by gram. But in this case, if you replace the atomic mass unit AMU by the gram, you don't have a molecule, a single molecule, but you have a greater number of atoms or a greater number of molecules. Here, for example, this is a molecule, consists of atoms, 6 atoms, small atoms similar to each other, 2 other atoms, 1 atom in red, other element. Here are 3 types of elements. One element here, and the other element is in dark color, and the third one is in red. It is clear that the mass of this molecule is equal to the sum of the masses of these atoms, right? This is called the molecular mass, the mass of the sum of atomic masses of the atoms forming the molecule in AMU unit, which is a very small unit. If you replace the unit AMU in gram, the molecular mass in gram, we get what is known as gram molecular mass, or gram formula mass in this case of sodium chloride, for example. So the gram molecular mass is the same as the molecular mass but expressed here in grams. In this case, we have not only one molecule but a greater number of molecules. The gram molecular mass may be called molar mass. What is the meaning of molar mass? It is related to what is known as mole. The quantity of the matter that contains this number is very great number. This number is called a mole, which is 602 and 21 zeros. This greater number of molecules is present in the mole. What is the mole? The mole is a very great number produced when we replace the AMU unit by the gram. AMU is used to find the mass of one single atom or one single molecule. But if you replace the AMU by the gram, you have a great number of molecules. This is the great number of molecules, or the great number of atoms. Let's have an example. This is a molecule of water. One molecule of water, 3 atoms, 2 hydrogen atoms and 1 oxygen atom. The sum of one hydrogen atom is 1 AMU. This is the mass of another hydrogen atoms, 1 AMU. This is the one atom of oxygen. Its mass is 16 AMU. So the total mass of this molecule is 18 AMU. The AMU unit is very small. It is all these zeros and 166 grams. This number can be written as 1.66 by 10 to the minus 24 grams. Very small number. So it's not a practical unit for measuring masses. If we replace the 18 grams by 18 AMU by 18 grams, we have this quantity of water. This quantity of water contains this greater number of molecules. Avogadro's number. This is called Avogadro's number, discovered by the scientist Avogadro, who discovered this number. So this is the mass of one molecule. This molecule is invisible, very small in volume, cannot be seen, very small in mass. AMU unit. AMU unit is very small. Its value is 0.166 grams. Very small number. So to have a practical unit, replace AMU by gram. In this case, you don't have one molecule, invisible molecule, but you have a greater number of visible molecules. This greater number of molecule is this number, very great number of molecules. This number produced, why? Because you replaced this small unit by gram. This very small unit. This is a good unit, a bigger unit, the unit which can be applied, but this unit is very small, cannot be applied or used. In this case, you have this greater amount of water, which is called a mole of water. A mole of water means quantity of water contains this number of molecules, of Avogadro's number of molecules, and so on with any other compound. This is 1 mole of carbon. 1 atom of carbon, its mass is 12 AMU, but this quantity of carbon has a mass of 12 grams. 12 grams can be seen, but 12 AMU, it's the mass of 1 atom of carbon, which is very small, cannot be seen. But this is 1 mole, can be seen, can make any experiment on this amount of carbon. This quantity contains Avogadro's number of molecules. In the same way, this is 32.1 gram of sulfur. This is the mass of 1 mole. Here, if you count the number of atoms of sulfur here, Avogadro's number of atoms. If 32.1 AMU, this is the mass of 1 sulfur atom. But in this case, one atom cannot be seen. Okay, the same here. This is 1 mole, the mass of 1 mole, 55.8 grams, contains Avogadro's number, greater number of atoms of iron here. The same way, 63.5 grams of copper, quantity that can be seen. This is 1 mole, contains Avogadro's number, and so on. Lead, 260.8 grams of lead, 1 mole of lead, and so on with any other element. This is 1 mole of iron, 1 mole of mercury, 1 mole of copper, 1 mole of sulfur, 1 mole of helium inside the boron here. All this amount is 1 mole of sucrose, the table sugar, 1 mole of copper, 1 mole of aluminium. 1 mole of any substance can be seen because it contains a greater number of atoms or a greater number of molecules. Avogadro's number of atoms or Avogadro's number of molecules. These are samples. 1 mole of zinc can be seen, contains Avogadro's number. 1 mole of carbon, 1 mole of magnesium, 1 mole of copper, 1 mole of sulfur, 1 mole of silicon, 1 mole of lead, 1 mole of tin, and so on. I hope that you understand the meaning of mole. That's everything I want to say today. You can say goodbye.